All right, today we're diving into two huge ideas that could seriously reshape our world. One is about how to stop making a mess in the first place, and the other is about how to clean up the one we've already made. Let's get into it.
So, it all starts with this number, 100 billion tons. That's a mind-boggling figure, right? Well, according to the folks at Circle Economy, that's roughly how many raw materials, we're talking metals, minerals, fossil fuels, the whole shebang, we pull from the Earth every single year.
Now here's where it gets really wild. What happens to all that stuff we extract? Over 90% of it is wasted. Yep, it's used once, maybe, and then just thrown away. Think about all that lost value. It's just staggering.
And that gets you thinking, doesn't it? What if waste isn't just a fact of life? What if it's actually just a massive flaw in our design, a bug in the system that we could, design our way out of?
So here's how we're going to break it down. First, we'll look at our current throwaway world. Then we'll explore how we could redesign the entire system. After that, we'll zoom in on a wild technology for cleaning the air itself. And finally, we'll see how these two different paths could lead to one much greener future. Okay, so first things first. We have to understand the system we're in right now. Most experts call it a linear economy, and its philosophy is dead simple. You take resources, you make something, and then you waste it. That's it. Take, make, waste.
And this diagram just nails it. You can see the problem so clearly. The linear model is just a one-way street, right? From the resource pile straight to the landfill. But look at the circular model. Everything loops back. Materials stay in the system over and over again. It's a total paradigm shift.
Let's just put them right next to each other. The old way, take, make, waste. The new way, it completely flips the script. We're talking reuse, repair, and regenerate. See, it's not just about doing less damage. It's about actively trying to do more good. So, how do we actually make that happen? This brings us to our first huge solution, redesigning the system from the ground up, using the principles of the circular economy.
The Ellen MacArthur Foundation boils it down to 3 core principles, and they're brilliant. Number 1, you design out waste and pollution from the very start. It's not an afterthought. Number 2, you build things to last, keeping products and materials in use for as long as humanly possible. And number 3, you go beyond just not harming nature and actually work to regenerate it.
And to put this into practice, there are frameworks like this, the 10R hierarchy. This goes so far beyond reduce, reuse, recycle. It's a ladder of priorities. Right at the very top, the most powerful thing you can do is refuse. The best way to deal with waste is to not create it in the first place, right? Then you go down the list, repair, refurbish, remanufacture, and you'll notice plain old recycling is way down there, mostly because it often lowers the quality of the material.
And this chart really just shows you the sheer scale of the opportunity ahead of us. Right now, our global economy is less than 10% circular. That's it. Why? Well, because our entire industrial world, our supply chains, our habits, it was all built for that old take, make, waste model. The potential to change that is just massive.
And you know who's taking notice? Governments. They're starting to see this isn't just some environmental thing. It's a huge economic opportunity. It's a way to fight climate change, cut our dependence on scarce resources, and hey, create a ton of new jobs and industries in the process.
Okay, so the circular economy is our blueprint for stopping the leak, for preventing all that future waste and pollution. But what about all the pollution that's already out there? I'm talking about the legacy stuff, like all the extra carbon dioxide that's already in our atmosphere. And that's where our second big idea comes into play. Think of it like a technological cleanup crew for the sky. It's called direct air capture, or DAC for short.
Now, for the longest time, a lot of experts figured DAC had to be insanely expensive. This chart, called the Sherwood plot, shows the old way of thinking. Basically, the price of grabbing something goes through the roof as it gets more diluted. And since CO2 is super dilute in the air, everyone just assumed DAC would be way too costly. But some new innovations are seriously changing that map.
So how does this stuff actually work? Well, in simple terms, it's a two-step dance. First, you pull huge amounts of air through a filter, kind of like this honeycomb structure. It's coated with a material that acts like a sponge, soaking up only the CO2 molecules. Then, in step 2, you use low-temperature steam to gently wring out that sponge, releasing a stream of pure, concentrated CO2. You can see the cycle right here. On the left, you've got regular air flowing through the filter, and those little CO2 molecules are getting stuck to the walls.
Then, on the right, you introduce steam. It heats things up just enough to release the CO2, which you can then collect and store, or even use.
And here's the kicker. Thanks to these new smarter systems, the potential costs are just plummeting. The National Academy of Sciences looked at older systems and put the cost somewhere between $88 and $228 per ton. But with more R&D, a future cost of under $50 a ton? That's looking totally achievable. That's a game changer.
So, we have these two incredibly powerful concepts, right? One is this huge top-down redesign of our whole economy. The other is a super targeted technological tool for cleaning the sky. So, how do they fit together? Well, they're not fighting each other, they're perfect partners. The circular economy is our long game. It's how we stop polluting for good. Direct air capture is the special tool we need right now to deal with the mess we've already made, the carbon that's going to hang around for centuries unless we physically pull it out.
Here's the easiest way to think about it. The circular economy stops the leak in the overflowing bathtub. Direct air capture is the mop you use to clean up the water that's already all over the floor. You can't just do one. You absolutely need both.
And that leaves us with this final thought. If we can combine a regenerative economic model that works with nature and a restorative technology that can actually undo the harm we've done, can we finally build a future that's truly sustainable? The tools are here. The real question is, are we ready to start building with them?